Welcome to the ET380 how-to video for Passive Filters Lab. Okay, let's start with the RC Passive Low Pass Filter. RC meaning resistor capacitor. Okay, let's start in multi-sim, and I built the simple filter circuit. And let's go ahead and we're going to use the Agilent function generator and the Tektronix scope. So let's find our function generator, and let's connect that. We're going to use channel 1. Let's open that up a little bit. Yeah, there we go. Let's grab a ground for our scope. Good. And what we're going to do is we're going to open up our function generator, sine wave, and we're going to set it up for 10 volts. And what we're going to look for is, once we change the frequency, once it gets to 7.07 volts, that's going to be our cutoff frequency. So here we are. Let's open up our scope. And let's start our simulation. Bring this down where we get 10 volts in there. And let's go to measure, let it do the work for us. And go to peak to peak. Okay, so what we're going to do is we're going to change our frequencies. So let's go to frequency, and this one we have a ways to go, so let's go ahead and start cranking up our frequency until our voltage starts to lower. And 7.03 is close enough, so let's spread it out so make sure we get a good reading. And let's go ahead and check. Go ahead and open up frequency. And we come up with 61 kilohertz, and I think that's in our ballpark. Okay, here I'm showing our oscilloscope, and we have 61 kilohertz, and I did the calculation and I came up with 60.468 kilohertz. Pretty reasonably close. Okay, that's the method with the oscilloscope and function generator. Let's try another way. Multisim has a tool built in. Let's close out this. And let's get rid of all this, and we're going to need a source of our voltage here. So let's go here to sources, signal sources. Let's do an AC voltage. Get our ground. Okay, that's going to be our input voltage that we need, and we're going to go ahead and use a Bode plotter. Okay, and we're going to need a couple grounds. Okay, so we're going to measure our output from here and our input from here. And let's go ahead and start our simulation. Open up our Bode plotter. And there we have it right there. And there's our curve. So let's grab our cursor and we're going to look for 3 dB. Shoot, I had it and I moved it. Let's try again. Right there, 2.997. Good. So if we look there, we come up with 60.286 hertz, which is right in our ballpark for our cutoff frequency. Okay, let's change the size of the capacitor. Let's go ahead and shut our simulation down. Let's open that, go to replace, and we need a 0.022. And I just saw it. Nope, one. It's a little tiny one. Getting there. And a little more. 2422. 0.0022. Perfect. Alrighty, so let's go ahead and start our, and let's go ahead and move our cursor over until we find 3 dB. And try again. And we're getting there. How about we do this? Let's go ahead and change this to megahertz and this to hertz. See if I could make it easier to get a hold of the 3 dB. Yeah, close enough. So we're getting 15.769 hertz. Let's check our calculation. Here I'm showing our Bode plot compared to our calculation. So we got 15.769 on our Bode plot, and our calculated come out for 15.392 kilohertz. Perfect. Okay, here's our RC passive high pass filter. We just rearranged the components in this configuration, and let's go ahead and try it. Okay, here I redid the circuit for our low pass using the Bode plotter. Let's go ahead and start our simulation, and you see that we reverse our curve. So let's go find 3 dB. And 2.9, that's good enough for us right now. So I got 61.831. Being our formula is the same, and the curve changed directions, but our frequency will be the same. So we got 61.831, which matched our calculation because it's the same formula. Okay, so here we have our high pass filter. Let's change our capacitor. Let's go to replace, and we're going to go back to our 0.022. Okay, and let's start our simulation. Move our cursor. Close enough. So we're at 14.9 kilohertz, which is close to our formula. At 2.9, okay, 15.7 at 2.9 dB. That's good. And you can see that we're blocking lower frequencies and we're passing high frequencies. So this would be a high pass filter. Here we're showing a passive series LC bandpass filter. We're going to use an inductor, capacitor, and a resistor in this configuration. Okay, here I have my LC bandpass filter, and let's open up our function generator, and we want to get it to 10 volts. Good. And we're going to set our frequency, and let's go ahead and open our scope. So here what we're looking for, let's go ahead and run stop here. Okay, what we're looking for is to find 10 volts because this is our center frequency. Let's see here. First thing we need to do is restart our run stop. There we go. And what we're going to do is keep moving up. Let's try if we go up and we could get to 10 volts. And I'm going to call that good. So we're at right at 210. Let's see if we get a little better than that. Yeah, that's good enough. 9.1, and we've got 220 kilohertz. That sounds like it's in the ballpark. Okay, here's our passive series LC bandpass filter with a close-up of our scope, and we have 220 kilohertz, and I calculated 212 kilohertz. That's very good. Okay, here we're back at our circuit. Let's go ahead and replace our capacitor with a 0.022. Go to replace. And there's a 2.4 right here. Oops. Now let's go ahead and start our make sure our power amplitude is 10. Good. Frequency. Let's open up our scope. Get them working again. And we're at 6. Let's go ahead and start dialing it in until we get 10. And perfect. So it looks like we've got 110 kilohertz. Let's go ahead and lock that in. And let's go back and check our calculation. Okay, back to our passive series LC bandpass filter, and here's a close-up of our scope, and we come up with 110 kilohertz, and our calculation's 107.3 kilohertz. I'm going to call that close enough to perfect. Here I'm showing a passive shunt LC band reject filter. Let's go ahead and try it multi. Okay, here we're back at our circuit. Let's go ahead and replace our capacitor with a 0.022. Go to replace. And there's a 2.4 right here. Oops. Now let's go ahead and start our make sure our power amplitude is 10. Good. Frequency. Let's open up our scope. Get them working again. And we're at 6. Let's go ahead and start dialing it in until we get 10. And perfect. So it looks like we've got 110 kilohertz. Let's go ahead and lock that in. And let's go back and check our calculation. Okay, I moved my points between the two, and I found out that the center point between the two, or actually the cutoff frequency, is 150 kilohertz, and the other extreme would be 290 kilohertz. So if I were to subtract those out, divide it by 2, find the center point, it comes out to 220 kilohertz. When I do the calculation, it comes out to 212.7 kilohertz, which is very good. Okay, here I built the shunt LC band reject filter in multisim. Let's go ahead and open up our function generator and make sure that we have 10 volts. Good. And let's open up our scope. And let's start cranking up the frequency here. And let's get this guy. Oops, let's start a simulation. There we go. Let's get some more here. Alright, so we're at 10, so we got a ways to go. And boy, it's all over the map here. Oh, there's 7.5 was. And we're going to call that good. So let's go ahead and hit run, stop, and we got 150 kilohertz. Okay. Okay, I found the other critical frequency. So we come up with 60 kilohertz. And 190 kilohertz at the other one. So if we go through and do the calculation, I'll come up with the center point of 125, which is so close to the 107 that we calculated. I'll call it good.